Welcome, and in this lesson, we're going to start working on the objective identify CPU and memory intensive processes, adjust process priority with renice and nice, and kill processes. Now, this objective is going to require multiple videos because we really have a lot that we need to learn how to do. So in this lesson, we're going to start off learning about pgrep and pkill. Now, these are tools that I find particularly useful when working and administrating a Linux system. So let's go ahead and talk about how they work. So we're going to learn a little bit about PS. If you're not familiar with PS at this point, what we can do is we can use PS to find and list processes running on our system. So we're basically getting all processes as a dump. Well, what pgrep does, it allows me to combine the grep utility with the PS utility. So instead of running PSAUX and grepping for something like gnome, I can actually do a pgrep on my command, so pgrep and then gnome, and it will return all of the processes. Now, if I want the process names, I can pass it the -L flag, and it's going to show me the name of the process. So let's just learn a little bit about using pgrep. The first thing I want to do is, I'm not sure if you've noticed, but I'm logged in a linuxacademy.com lab server. I've logged in twice inside of the same server. I'm logged in once as the user, and then again as the user root. So make sure that you have this set up where one is the root user or privileged user and another is a basic user on the system. So what we're going to do is we're going to make sure that we have installed HTTPD. So do a yum install HTTPD. If it's already installed on your system, make sure you do a systemctl start on our HTTPD service. So let's see if HTTPD is actually running now. I can use a pgrep and search for HTTPD. I might want to see the process name. So I can do a pgrep HTTPD-L. -L is going to show me the name of the process. It's HTTPD. Now, let's say that I come over here as my user, and I want to run something called VI. I can just do a VI test. What this does is it opens it up inside of our terminal. So let's say we need to figure out what processes a specific user is running on the system. I can do a pgrep-u, and then my username that I want to show all processes for. And that username, of course, in this scenario is the user. I'm going to pass it a -L flag, so that way I can see all of the process names that user has running underneath it. So these are all the processes that the user has running underneath it. Now, let's say I'm looking for a specific process. I started the VI process, which starts the VIM basic program. So I can do pgrep-u user-l VIM, and it's going to return just the VIM process. Right? So we're using the grep utility here as part of our PS to query processes on our system, and I pass it the parameter I'm looking for, VIM, and it's going to show up. If I pass it a VI, it's still grepping for everything that starts with VI, and so we're going to have that as part of our return. So if you notice, VI appears right here, and that's why both of those return. So it's combining the grep program with our processes. So now that we know how to do this, we've learned how to grep all processes for a specific user. Let's grep all of processes not owned by the root user. So I can do a pgrep-v. -v means the inverse. So I'm going to say all processes not owned by the root user. Well, there's all the process IDs. So now what I can do is I can pass it the -L flag or option, and it'll show me all of the process names not owned by the root user. So this is an inverse relationship. Now, this tool is going to come in handy when we're working with nice and renice. We're going to use this to be able to list all processes at a given time. So now that we've done this, let's take a look at the pkill command. Now, the cool thing about the pkill command is I'm able to pass it just the name of a process that I want to kill. But instead of passing it the ID like we can do with the kill command, which we'll learn a little bit out later on, I'm going to pass it the name of the process because we're using something similar to grep. So it's going to pull and kill all of our HTTPD processes. So if I do a pkill HTTPD and I do a pgrep now for HTTPD, we notice that there are no more HTTPD processes. Because what did pkill do? It grepped for all processes that are named HTTPD and it killed them. So instead of just killing a unique ID, it killed them all. Now, let's talk a little bit about kill signals. Kill signals is something that we need to understand as part of being Linux system administrators, as well as preparing for the Red Hat certification. Now, the kill command, if I do a kill-L, it's going to return all of my available signals. Now, these signals also apply to our pkill command. If I do the pkill command without any options or flag, what it's doing is it's actually saying pkill-15, or that's our number representation of it, or sigterm, and then the process name. So that's the default it's going to pass it. Now, what's the significance of 15? So let's take a look here and look for number 15. You see it says sigterm. So it's the same as passing sigterm like that or doing -15. Well, this kill signal is what's called a nice kill signal. What it does is it passes or causes a program to terminate. It says, please terminate, but terminate cleanly. Finish what you're doing, run any cleanup processes that you need to do to complete cleanly. And that's what it does. It's generally the best way to kill a program. But let's say that we have a process that's hung, or it's a malicious process that could be doing bad things on our system, and we want it to immediately terminate. What we need to do is we need to send a sig kill signal. So a sig kill signal is a -9 here. We see it available in our kill-L flag. When we do kill-L, we see our signals, and so we see sig kill here. And that's the same as passing sig kill. What that does, it says kill that process. Kill it immediately. Do not allow anything to block the process killing. Do not allow it to clean up. This is what we use, again, when we have a hung process, or when there's malicious process, or when we think somebody's doing something bad on our system, we want to immediately kill them. So let's talk about a few of the different kill signals. I do not expect you, and neither does any Linux certification out there, to memorize every single one of these kill signals. I do expect you to know about 6 or 7 different ones of them that are available in the downloadable study guide of this course. So the first one is kill signal 1. If I use pkill or just the kill command and pass it as signal 1. This signal is the same as sighup as we see here. So sighup means hang up. What it is, it's used to configure or reload termination, and also used to report a termination of a controlling process of a terminal. So this is similar to closing a terminal window. So if you were to hit the X here, it's going to send a sighup signal to all of our processes, which basically says we've hung up the connection to our terminal and it's no longer there. So that's what sighup is. Sigint, what that does, that's the same as keyboard interrupt. So if I were to hit Control-C on my keyboard right now, what that does, it sends a kill signal 2, which is sigint. And so that is, again, keyboard interrupt. So then we have kill signal 3, which is sig quit. Basically what happens is the process is sent by its controlling terminal requesting the process to quit. Then again, we've already covered sig kill, which is 9, to kill it without anything being able to block that signal. There's no way that we can block that signal. So that's for emergency situations. It's not always recommended because processes don't terminate cleanly. Then we have our default, which is what is passed if we don't pass it a kill signal, which is also -15, or again, that is sigterm, which is terminate the signal. Attempt to run all your cleanup processes that you can run up and terminate. Then we're going to learn this here shortly. This is pretty neat. It's signal 18, which is sig continue. Right? So sig continue means that we can actually stop a process using these kill signals, and that's actually 19, sig stop. We can actually stop the process and start it again using kill signals. So that's a cool demonstration that we're going to have. And then we have 19, which is sig stop, which says, hey, stop the process, right? Stop the process, make it so we can start the process again. Then we have 20, which is sig TSTP. So let's take a look at it here. Sig TSTP. This sends a stop that can be ignored, whereas our sig stop, our number 19, this cannot be ignored. This forces the stopping of a process. But our 20, our sig TSTP, does send a signal where it can be stopped if needed. So let's go ahead and complete this lesson, and let's complete it by cleanly booting a user from the system. So in order to cleanly boot a user from the system, what I'm going to do is I'm actually going to create another user and log into my system as that user on the same system. So I'm just going to do a user add and then my name. Let's make sure I set a password for that user. so I can log into my system. Now that I have that created, I'm going to go over to my second tab. And if you're not logged out of it, go ahead and just do an exit to log out of it, completely log out of your system. And then we're going to do an SSH user and then into your server lab IP address, which is the same machine we're connected on here. So what you need to do is on this other tab where we were logged in, make sure you hit exit a few times to exit out to your regular desktop, because we're going to log in as another user. So to do that, I'm going to log in as that Anthony user I just created on the same lab server that we have running. So if I come over here and I do a W, what I notice here is I have an Anthony user logged in. Currently they're in the bash terminal. Now my W program is really cool because it shows our current uptime, the number of users logged into the system, and the current 1, 5, and 15-minute load averages on the system. So for example, if I were to type VI over here in this terminal and do a W again, I could see that the Anthony user is using the VIM program, because we know when we type VI, it opens up VIM Lite. I want to kill all processes that this user has started. I have two options for this. I can use pkill. Now, by default, the pkill will send the -15 signal, which is our sig term. Now, what I need to do is I need to kill all processes that were started by the user from their terminal window. So because I did the W command, I can get their TTY ID, which represents their terminal window ID. So I can say pkill-t, and then we'll just paste in the PTS/1. By doing this, it's going to close all of the user's program. We already see that it closed it here. And we see that the user has been booted from the program, but the user is still logged into the system. So I can do a pgrep-u for the user Anthony and view all the processes still running. So you notice it killed everything that was launched from our terminal window. But we didn't launch the SSH or bash program from our terminal window because that's just what process that was started when we logged in. So what we need to do is we just need to kill the SSH one. So I can do a pkill and then for the user Anthony SSHD, because if I didn't pass it the -u and specify the Anthony user, it would kill it for all users on the system. So if I do that here, you'll have noticed that we have now been terminated or booted off the system, and the user also no longer shows up here. So that concludes it for this lesson. Go ahead and complete this lesson and move on.